Hello. Today I'm going to walk you through how to analyze some data, the data for our within subjects lab in JASP. I'm doing that because we can't do a one-way repeated measures ANOVA in SPSS with the tool pack that we have. And I didn't want to hold you responsible for learning a whole new set unless you choose to do a within subjects experiment for your own experiment. So here's the data set. I want to just kind of show you some differences. One thing you might notice is that when we were, so this is one participant and it has three different measurements here. Direction of rotation is another variable that we're not going to look at. We're just going to look at understated, accurate, and overstated. And hopefully if you've read through the lab activity already, you understand kind of a little bit about what this means. It's actually an experiment that we looked at a few weeks ago where they're basically giving visual feedback in terms of rotation of the neck, and this is the degree that they can go before they feel pain. And so if you notice here, this is one participant and they have three different measurements because it's a within subjects. Each one of these conditions they were exposed to. This is a second participant, and so on and so forth. Whereas what we saw in the between subjects is we saw one group with the data, and then we saw another group with the data. And so with between subjects, you stack the data. Here you have different columns. Here we have three levels of one independent variable, so we have three columns. So we're going to go up here to repeated measures ANOVA. And the one thing that's kind of neat about this program is it starts to kind of show you what that table is going to look like for our within subjects ANOVA. And so what we need to do is go up here, we're going to type in visual feedback, and then we're going to say understated, accurate, overstated, and then that should all populate down here. And then we need to go in and fill these in the right spot. So okay. So then we want to go down and do some, so if we look over here at the data, it's going to tell us that our Mauchly's test of sphericity indicates the assumption of sphericity is violated. So this is for a within subjects or repeated measures design. This is something that we need to that has to be considered. And so if it's violated, we have to adjust our degrees of freedom to make sure the analysis is accurate. So it can be kind of likened to the homogeneity of variance in a between subjects ANOVA. And so it's basically looking at it's the condition where the variance of the differences between all combinations of related groups or levels are equal. And so here we can see it's violated, and I think it seems like it's violated quite often in experiments. So in this, we're going to go to the assumption checks, and we already did a sphericity test, so we're just going to do a sphericity correction. We want to do not a planned contrast, we want to do a post hoc test. I forgot to click over visual feedback here. Did that there. We're just going to forget about the descriptive plots. All right. Okay, so this is what you're going to be interested in looking at. This greenhouse geyser is the one that we're interested in. And we look here, this is one of your degrees of freedoms you're going to report. This is that F value. And then here's the P value. All right, so here's our output. This one is the one that you're interested in. And you're going to see here's that F value you're going to report. Here's that P value you're going to report. And then we'll get to the degrees of freedom in a minute. So even though now we've corrected it, but this is still your degrees of freedom that you're going to report. And then this would be your other degrees of freedom that you would report. Here's those post hoc tests. And so looking at this, it's showing you the mean difference between accurate and overstated, which direction it's going, showing you it's significant.